Hello and welcome to all students. In this lecture, we learn about elementary probability theory. In the previous lecture, we have defined what is meant by probability. So, to define probability, in the last lecture, we have seen what is random experiment, what is the event of the random experiment, okay, and what are the outcomes, what is the outcome of the random experiment. Okay, so probability, we find the probability of event of a random experiment. Okay, so and suppose suppose there is one random experiment and E be the event of that random experiment, and suppose S is the sample space of that random experiment. Then then we saw then we saw what is probability of that what probability of that event E, and that probability is given by the number of outcomes in event E divided by the number of outcomes in the sample space S, okay, or the total number of outcomes of the random experiment. Okay, what is S? S is a sample space of the random experiment. So sample space means it is the set of all possible outcomes of the random experiment. So probability of an event E is nothing but number of outcomes in event E divided by number of all possible outcomes. So that gives the probability of the event E of that random experiment. Okay. So based on this, we have to solve. Today we solve some problems. So let us take first question. Question number 1. Question number 1. 3 coins are tossed. Find the probability of getting 3 coins are tossed. 3 coins are tossed. Find probability of getting first, getting no head. B is getting 2 heads. C is at least 2 heads. And D is at most 2 heads. So let us write the answer for this question. Answer is okay. So our random experiment is tossing of 3 coins. Tossing of 3 coins. Okay. So as this is the random experiment, then what are the outcomes? So outcomes, the set of all outcomes is nothing but the sample space of this random experiment. So outcomes are, suppose first coin gives head, second coin gives head, third coin gives head. Okay. So first possibility is we get all heads. Second possibility I am writing here, head, head, third coin gives tail. Third possibility, head, tail, head, tail, head, head. Okay, or it may happen that we get head on first coin and tail on remaining coin. Tail, head, tail, 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 head, or we get all tails. Okay, 1 2 3 4 5 6 7 8. So these are the 8 possibilities that we get. Okay, so n of s, the total number of outcomes are 8. N of s is 8. Now we go to the first case. Our first case is the event of getting. Let a denote event of getting no head. No head means this event A must have only one outcome, and that outcome is all tails, means no head. So no, n of A is 1. There is only one possibility. Okay, therefore we can find the probability of A now. Probability of event A is, by formula, it is nothing but n of A divided by n of s. Okay, and probability of event A is equal to n of A is 1 and n of s is 8. So this is the probability of getting no head. 1 upon 8 is the probability. Okay, now go to the second case, case 2, or a B case. B. Okay, B case is 2 heads. Let B be the event of getting two heads, means set B contains these possibilities: head, head, tail, head, tail, head, tail, head, head. Okay, 1 2 3. So there is no other possibility, so only 2 heads. So total number of outcomes in B are 3, and okay, therefore we can write probability of event B. Probability of event B is equal to number of outcomes in B divided by number of outcomes in sample space. So n of B is 3 and n of S is 8. So probability of event B is 3 by 8. Okay, is 3 by 8. So this is the probability of event B, this 3 by 8. Now let us go to the case third. C case is at least 2 heads. So let us call C be the event of getting event of getting at least two heads, at least two heads. Okay, okay, therefore the event C contains outcomes at least two heads means two or more than two heads. Okay, so see here three heads, three heads you can take here, and then two heads, head, tail, head, tail, head, tail, head, head. Okay, so 1 2 3 4. So in this case the total at least two means two or more than two, so two heads and three heads. Okay, so these are the outcomes of this event, and the total number of outcomes are n of c is equal to, it is 4, and therefore we can write probability of event c, and it is equal to n of c divided by n of s. Okay, so n of c is 4, n of s is 8, and it is 1 upon 8. Therefore probability of event c is 1 upon 8. Okay, so this is our third case. Now go to the case fourth, D case. D case is a case of getting at most two heads. Let us call D be the event of getting at most two heads. Therefore set D contains the outcomes. So at most two heads, the meaning is that no head, one head or two head. So no head means all tails, one head means head, tail, tail, then tail, head, tail, 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 head. So no head, one head and two heads means head, head, tail, head, tail, head, tail, head, head. So these are the possibilities. Okay, so n of D is equal to, so how many outcomes are there? 1 2 3 4 5 6 7. So n of D is 7, and therefore we can write the probability of event D, it is equal to n of D divided by n of S, and n of D is equal to, n of D is 7, n of S is 8. So finally we have probability of event D is equal to 7 by 8. 7 by 8. Okay, so this is the end of this problem. Now let us go to the next question. Question number 2. Question number 2. A perfect cubic die. A perfect cubic cubic die a perfect cubic die is thrown full stop. Find the probability that find the probability that first case is an even number comes up, an even number comes up, okay, and second case is a perfect square comes up. Okay, so let us write the answer for this question. Okay, here the random experiment is throwing a cubic die. Throwing a cubic die. Okay, so in this case the all possible outcomes are, on the upper face either we get 1 or 2 or 3 or 4 or 5 or 6. So in this experiment the all possible outcomes are 6. Therefore sample space has these much outcomes. Okay, so n of s, the total number of outcomes in a sample space are 6. N of s is 6. Important, we need this n of s while finding the probability. Okay, so n of s is 6. Now let us go to the case first. Case A. In first case, event is that an even number comes up. Let us call A be the event of getting an even number comes up. Okay, an even number comes 1 minute. Okay, an even number comes up. So in this case the possible outcomes are, even number means, so out of these 6 numbers, even numbers are 2, 4, 6. These are the even numbers, and therefore number of outcomes in this case, in this event, are 3, and therefore the probability of event A is n of A divided by n of s, but n of A is 3, n of s is 6, and it is equal to 1 by 2. So probability of event A is 1 by 2. Okay, now let us go to the second case. Let us go to the case 2. So okay, in the case 2, a perfect square comes up, means it is a event. Let us call B be the event of getting a perfect square comes up. A perfect square comes up. Okay. Therefore, B contains possibilities perfect square 1 and 4. Only these two numbers are perfect square. Therefore, n of B is equal to 2, and therefore we can write the probability of event of getting a perfect square is n of B divided by n of S. It is equal to 2 divided by 6 equal to 1 upon 3, and therefore the probability of event B is 1 upon 3. Okay, so now in this way we solved two examples based on the probability. Okay, now let us, so this is the end of our lecture. Thank you. Thank you.